Hello, once again. We're still learning how to find the parameter of two-dimensional objects that involve circles. And let's have a look at the shape that we have in hands here. As you can see, it is composed of a semicircle as well as a rectangle. And remember that the parameter is we calculated by adding all sides to close the shape. As you can see here in the semicircle, the distance from the circumference to the circumference passing through the center of the circle is actually 8 centimeters. Half of the 8 is 4, which gives me the radius. It's the distance from the center to the circumference, and that's what I actually need to calculate the circumference of this semicircle, or the length of the arc in this semicircle. So the distance from the center to any point at this arc is actually 4 centimeters, which leaves the height of this rectangle as 3 centimeters. So if you start at here and you go down 3 plus go left 8 plus go up 3 plus the length of the arc, which we are going to calculate right now. So the semicircle is actually half of a circle, and the radius is d over 2, the diameter over 2. So it's 8 over 2, or half of the 8, which is 4. So since we calculated the radius, or we found out the radius here, I can immediately write the formula of finding the length of an arc in a semicircle, which is half of 2 pi r. The circumference of a full circle is 2 pi r, and the length of the arc in a semicircle, or in half of a circle, is actually half of the 2 pi r. And remember, where did the half come from? Just as we explained in the quadrant previously, the angle in here that is opposite to the arc is 180. So 180 over 360 will come down, if you simplify it, to 1 over 2. So you either write it as 1 over 2 of 2 pi r, or 180 over 360 of 2 pi r. And it is important for you to know this piece of information when we come to calculating the area or the parameter of any sector or any section that's taken from a circle. Since we decided, or we came to know, that the radius is actually equal to 4, and after we wrote that general formula of finding the length of the arc in a semicircle, the next step is substituting in this general formula, which is going to be half times 2 times pi times 4. And write your answer in terms of pi at first. So half times 2 will come down to 1, and 1 times 4 is actually 4 pi. 4 pi centimeter, because the length of the arc is measured in millimeter, centimeter, meter, kilometer, and so on. Then write the answer as a decimal when you insert this in the calculator. So the answer correct to 3 significant figures is 12.6. You stop at the 5, look at the right, 6 is gonna bring 5 up. So it's 12.6 centimeter, and this is correct to 3 significant figures. Well, this is the length of the arc. Let's go together to the shape here. And as I explained previously, let's consider that this is my starting point. So if I go down, the length of this side here is 3 plus, if I go left, the length of this side is, the length of this side is 8 plus, remember the parameter is adding all sides to close the shape. And then you go up and the length of this side is 3 plus back to the starting point, and the length of this arc is actually 4 pi. So the length of this arc is 4 pi, which is equal to half times pi times 2 times r, which is 4. And if you insert this in the calculator, you're gonna find the parameter in here, and the answer is gonna be written in centimeter because it's the length or the parameter which is adding all sides, and each side is actually given to us in the question in centimeter. Let's go back to our presentation and let's carry on here. So the parameter of the shape, it's adding up the lengths of all sides. So the sum of the straight sides, just as I explained previously, so plus the length of the arc. So the straight sides are 3 plus 8 plus 3 plus 4 pi, and if you insert this in the calculator, you're going to end up with 26.6. So stop at the 5, look at the right, 6 is gonna bring 5 up, so the final answer correct to 3 significant figures is 26.6 centimeter. I would like you to think of this question in the exact same way. Please watch the video again if you struggle with any of the steps. As you can see here, we have two typical semicircles. So if you calculate the length of this arc, it's going to be equal to the length of this arc as well. And another typical small semicircles. So if you calculate the length of this arc, it's going to be the exact same as the length of this arc. One more thing that I would like to hint here is the length of the radius, which is the distance from the center to the circumference. So the diameter here is 12, so the radius is going to be 6, half of the 12. And the diameter of the small semicircle is 4, so the radius is half of 4, which is 2. So the length of this arc is going to be half times 2 times pi times 6. All this times 2 because I have 2 arcs with the exact same length. And then you're going to add to all this the length of this arc, which is half times 2 times pi times 2. And then you're going to multiply it all by 2, and then you add it. I'm going to say thank you so much for watching, sharing the link of this video, and subscribing to my YouTube channel.